Artemis II is the most dangerous mission NASA has attempted in over half a century. Unlike the International Space Station, which orbits just 250 miles above us, the Artemis II crew will be 230,000 miles away. If a major system fails, there is no safe haven and no backup vehicle. Space is unforgiving, and when you're traveling at 25,000 miles per hour, going wrong can happen in milliseconds. Here is the straightforward breakdown of the fail states and the emergency protocols for humanity's return to the deep. The launch, 0 to 120 seconds. The most violent phase of the mission is the first 2 minutes. The Space Launch System, SLS, is packed with over 2 million pounds of explosive propellant. If the flight computer detects a deviation in the solid rocket boosters or a catastrophic engine failure in the core stage, the Launch Abort System, LAS, is triggered. The LAS is a solid fuel rocket motor sitting on top of the Orion capsule. In an emergency, it fires with 400,000 pounds of thrust, enough to pull the crew away from a failing SLS rocket with a force of 15 Gs. Within seconds, the capsule is pulled miles away from the fireball, where it jettisons the abort motor and deploys parachutes for an ocean splashdown. This system is active from the launch pad up until the rocket reaches an altitude of about 300,000 feet. Artemis II includes a specific safety phase that Apollo did not, the High Earth Orbit, HEO checkout. After reaching space, the crew doesn't immediately head for the moon. They stay in a massive elliptical orbit around Earth for 24 hours. This is the go/no-go point for the entire mission. The astronauts will test the life support systems, ECLSS, and the European Service Module's maneuvers while they are still close to Earth. If the carbon dioxide scrubbers fail or the power systems glitch, the crew can simply fire their engines and return to Earth in a few hours. Once they ignite the upper stage for the trans-lunar injection, TLI, they are committed. At that point, a return trip takes at least 4 days, regardless of the emergency. The most critical single point of failure is the European Service Module, ESM. It provides all the air, water, and propulsion. If the ESM's main engine, the AJ-10-190, fails to fire during the lunar flyby, the crew relies on the free return trajectory. NASA engineers have designed the path so that Earth's gravity and the Moon's gravity act as a cosmic slingshot. Even with a dead engine, Orion's current path is mathematically guaranteed to loop around the Moon and head back toward Earth. However, if there is a massive leak in the oxygen tanks, similar to Apollo 13, the crew would have to power down all non-essential systems, including heaters and computers, to survive the 4-day coast back home. Orion's digital systems are more efficient than Apollo's, but they're also more vulnerable to radiation, which is why the ship has 3 redundant flight computers: re-entry, Mach 32, and the heat shield. The final fail state occurs during re-entry. Orion will hit the atmosphere at 25,000 miles per hour. The friction creates a sheath of plasma around the ship at 5,000 degrees Fahrenheit. During the uncrewed Artemis Worst test, NASA noticed that the Avcoat heat shield charred and chipped away in a way that wasn't predicted by their computer models. If the heat shield delaminates or loses too much material during Artemis II, the structural integrity of the capsule would be compromised, leading to a catastrophic breach. To mitigate this, Orion uses a skip re-entry maneuver. It dips into the atmosphere to slow down, skips back out into space to cool off, and then enters a second time. This reduces the heat load and the G-forces on the crew. Even after surviving the heat of re-entry, the mission can still fail in the last 20,000 feet. Orion uses a sequence of 11 parachutes. First, 2 drogue chutes stabilize the capsule, followed by 3 main parachutes that slow the ship from 300 miles per hour to just 20 miles per hour for splashdown. While Orion is designed to land safely with only 2 of its 3 main parachutes, a failure of 2 or more would result in a high-impact splashdown that the crew likely wouldn't survive. Conclusion: every phase of Artemis II has a fail-safe, but the margin for error in deep space is almost zero. NASA isn't launching Artemis II because it is perfectly safe. They are launching it to find the limits of the hardware. Success means moving one step closer to Mars. Failure means a total reassessment of our future in the stars.